For the next two lessons, we're going to be doing algebraic proof. We are going to start off with GCSE level algebraic proof, and then tomorrow we're going to do some further maths level algebraic proof. So I'm going to do a couple of examples just for what you would need for GCSE, the normal GCSE. Bear in mind this is still considered quite a tricky topic, so these are grade 8, grade 9 type questions. For algebraic proof, there are a couple of rules that you'll want to remember. If a question talks about an integer and it doesn't say whether it's positive or negative, you're just going to use n. If a question talks about an even number, you're going to use 2n. And if it talks about two even numbers, if they're just two even numbers and they're not related in any way, you're going to use 2n and 2m. If they're related in some way, so say an even number and the next consecutive even number, then you would use 2n and 2n plus 2. So if there's nothing to relate them, you need to use different letters. If they are related, for example by being consecutive, you must use the same letter. Then for odd numbers, you've got 2n plus 1. And again, if it talks about two different odd numbers, you need to use a different letter. But if it talks about consecutive odd numbers, you usually want to use 2n minus 1 and 2n plus 1, because then these cancel when we add them together. But you can also use 2n plus 3. So that's n is just for an integer, 2n, 2m, 2n plus 2. They are even numbers, 2n plus 1, 2m plus 1, or 2n minus 1, 2n plus 1, 2n plus 3. Those are odd numbers. Also, if a question mixes odd and even numbers, 2n would be the even number. If the numbers are related, so if it says and the next odd number, you would use n. But if it says an even number and an odd number and they're not related in any way, you would still need to use different letters, because at the moment this means the odd number immediately after the even number that you've used, because the n makes them related. This is 2n, this is that same number, 2n plus 1. Here, this is 2n, an even number. This is 2m, any other even number, plus 1, making it odd. So the first GCSE normal maths style question we're going to do is prove algebraically that the sum of 3 consecutive integers is always a multiple of 3. So it doesn't say odd or even in there, it says algebraically first of all, so we're not just going to start adding integers together, we're going to use an algebraic representation. It doesn't say if they're odd or even, so I'm going to choose n as one of my integers. It does say that they're consecutive, so they are related, which means I can use n in all of my algebraic representations. So this is the number n. This is the next one, consecutive. This is the next one, consecutive. And I need to show that it's a multiple of 3. We are doing the sum, so I'm going to add them together. n plus 1 plus n plus 2. I've put the brackets round to show that they are individual numbers. So that's one number, that's the next number, that's the next number. But I actually don't need the brackets. So my next step would be to just take the brackets out, and then I can add them all together and I will get 3n plus 3. That is not proof enough. We're going to factorise the 3 out, and then we are going to write a sentence which is always a multiple of 3. You might have noticed that here for the 3 consecutive integers, we could have had n, and then to its right we could have had n plus 1, but to its left we could have had n minus 1. Then when we add them together, n minus 1 plus n plus n plus 1, we actually end up with, taking out the brackets now because it's addition, so I can just add 3n minus 1 plus 1 makes 0, they cancel out. So I actually just get 3n, which is a multiple of 3. And that's it. Okay, next one. Prove that the product of two odd numbers is always odd. So, product is an important word, and it's two odd numbers. It doesn't say that they're related. It's not two consecutive odd numbers. It's just two odd numbers. So I'm going to use 2n plus 1, and I'm going to use 2m plus 1. And because it's the product, it means we're multiplying them together. So if I multiply this out, I get 4nm plus 2m plus 2n plus 1. Now, an odd number takes this form, 2 times something plus 1 on the end. So I need to turn this into 2 times something plus 1 on the end. So I'm going to take 2. Then I'd have 2nm plus m plus n, and that is all of this bit, plus 1. So I've now got this, so that it's 2 times something plus 1, so I can say which is an odd number. Last one, this is slightly different. A is an odd number. Prove that 3a plus 2 is always an odd number. I'd like you to pause the video and have a go at this yourself. Then I'm going to go through it and you can check whether you're correct or not. So pause now and have a go. Okay, so a is an odd number, which means we can write a as 2n plus 1. Then if I substitute that into here, I get 3 times 2n plus 1 plus 2. And that is going to equal 6n plus 3 plus 2, which is 6n plus 5. To show that that is an odd number, I need to put it in the form 2 times something plus 1. So I'm going to split this 5, so it's plus 4 plus 1. This gives me the plus 1 I need on the end. Now I just need to change this into 2 times something, which I can do. If I take 2 out, I get 3n plus 2 plus 1. So I've got 2 times something plus 1, which is an odd number, and I should write that. I'm not sure if you can quite see the bottom of my board, but I should write a sentence at the bottom just saying which is an odd number. Okay, that should be enough examples for you to have a go at the worksheet that I've put up. I think you have seen this worksheet before, and this is the standard maths algebraic proof. Then tomorrow I'm going to go through another few examples and put up a worksheet, and that will be for the further maths algebraic proof. If you get stuck on any of the questions on the worksheet I've put up, please let me know on Show My Homework, and I will do a video going through whichever one you've got stuck on.